Hello, today we are going to be reviewing for your quarter one common assessment benchmark. So the first one, a long distance phone company charges $15 a month plus 5 cents per minute for calls. If the family's total monthly bill is $51.90, which has $17 included for internet, how many minutes did they use? So we need to set up an equation here, and I always have my students start with the total because 9 times out of 10 your total is the largest number and it's the easiest number to find. So your total is the number that goes after the equal sign. So it said that the family's total was $51.90. Then I have my students look for the coefficient, because if you know what you're trying to find, so in this case we're trying to find how many minutes, your coefficient is going to be the number that also talks about minutes. So if we're trying to figure out the number of minutes, it said that it costs 5 cents per minute. So our 5 cents is our coefficient. And then you're just trying to figure out what to do with the other numbers. So every month it costs $15 plus there's $17 for internet. So we are just going to add that on to the amount that their minutes is going to cost them. So here's our equation. So now we're just going to solve. So first step is to simplify by combining like terms. So I'm going to take my 15 plus my 17, and that's going to give me a 32. Next step is to subtract the 32 from both sides, because now we just have a basic two-step equation. We're going to be left with 0.05x equals, and then a 51.90 minus 32 is $19.90. And then our last step is to divide by that 0.05 on both sides. So 19.9 divided by 0.05 gives us 398. So our answer here is A. All right, next one. Which number is closest to point A on the number line given? So the first thing that I notice is A is in my negative, so I know it's going to be a negative number. So A and B are negatives, C and D are not though, so I know for sure that C and D are not going to be my answers. So now I'm just looking at which one of these is closest. So to figure out what 3/4 equals, so negative 3/4, to change it to a decimal, remember you just take numerator divided by denominator. So 3 divided by 4 gives you 0.75, and then just put that negative in front of it, so it would be negative 0.075. So if I were to plot that, it would be somewhere around where B is at. So let's see if the square root of 6 is closer. So square root of 6, you can use your calculator, and it will tell you what your decimal is, or you can approximate by using your perfect square roots. So the square root of 6 is going to be just to the left of our negative square root of 4, so that is going to be right in that area with A. And then if you also found its decimal, you get the around 2.4, 2.5, and then put that negative in front of it, and as you can see, that would be the closest to A. So our answer here is B. Number 3, order the given numbers from least to greatest. So I see that I have some negatives and positives. So if I'm plotting these on a number line, my numbers to the right are the greatest numbers, and my numbers to the left are my smallest numbers. So I do know that my negatives are going to come first. And if you guys look at A and C, positives come first, so we know it's not going to be A or C. But looking over here, now we just need to figure out which one's the smallest. So the easiest way to do this is to change all of these numbers to decimals. So again, to change a fraction to a decimal, you're just taking numerator divided by denominator. So if I took 11 divided by 6, that gives me a 1.83 repeating. The square root of 19 is approximately 4.36. 0.23 is already a decimal. 6 divided by 5 is 1.2, and then I already have my -2. So looking at my numbers here, again, my smallest ones are going to be my negatives, and if you notice, -2 is going to be the smallest, and then the next one would be our -1.83. And I could already tell that B was going to be my answer without even changing these to decimals, because the only answer that had negatives first was B. Notice how D does start with -2, but then my negative ends up down here. So that one just made the most sense to begin with, but you can double check your answers by changing them to decimals to see if they are in order or not. All right, next one, estimate the value of -3 pi squared. So a number shoved up next to a variable, or in this case a symbol, means that you're multiplying. You have to follow your PEMDAS rules, so we do need to take pi squared first. So we do have a pi key in our calculator. Every pi key is different. So my pi key is down here. So I'm going to take pi squared, and that gives me about 9.87. And then we just take that times our -3. And that gives us approximately -29.6. And if we were to round that to the nearest whole number, it would be about -30. So -30 is all the way down here for D. Some calculators you can type in the -3 pi squared automatically, but some other calculators you might have to do your pi squared first and then take it times the 3. All right, next one, name the largest number. So same thing, I would change all of these to decimals to figure out what is the largest number. So if I were to take the square root of 45, that gives me about 6.7. 5 times pi is about 15.7. Then that's already a decimal. And then remember, when you have a number out front of a square root symbol, that still means that you're multiplying. So you can take 3 times the square root of 3, and that gives you about 5.2. So I have 6.7, 15.7, 1.5, and 5.2. So my largest number here is my 5 pi. So that is also going to be A. All right, back side here. So top part is we need to classify the given numbers as rational or irrational numbers. I always tell my students that it's easier to classify irrational numbers first because there's less of them, which means everything else would be rational. But the definitions are: a rational number is anything that can be expressed as a fraction. So those can be whole numbers, integers, decimals that stop, perfect square roots, fractions. So there's a lot of rational numbers. And then irrational numbers are everything else. So these are non-perfect square roots, as well as decimals that go on forever and do not stop. Okay, so like looking at the first one here, like I said, the definition of a rational number is anything that can be expressed as a fraction. So 6/7 is a fraction, so I know that's rational. Pi is a number that goes on and on forever and it never repeats, so that is the definition of a irrational number. 0.81 repeating, that is a decimal that goes on forever, but since it repeats, it makes it rational. So that would go down here in the rational box. And next one, we have a decimal that goes on forever, but it doesn't repeat. So that means that that is irrational. I have a non-perfect square root, which means that no number times itself would give you 42. So a non-perfect square root would be irrational. And then any whole number can be expressed as a fraction because we can put it over 1. So that means that it would be a rational number. All right, number 7. So the distance from Denver to Philadelphia is approximately 1.728 times 10 to the 3rd miles. 5 times 10 to the 2nd miles. Which operation would you use to find the distance from St. Louis to Philadelphia? So they gave us this whole distance from Denver to Philadelphia, and then they gave us this distance from Denver to St. Louis. And what they are trying to find is the distance between St. Louis and Philadelphia. So when you're given the whole distance and then given part of it, and you're trying to find the other part of it, what operation do you guys think we're going to do here? It would be subtraction, okay? Because if you were to add the Denver to St. Louis and add the St. Louis to Philadelphia, that will give you the whole entire distance. So when you're missing a part of it, then you need to subtract it to figure out what that part is. All right, next one, we need to simplify. So I see scientific notation, and the operation that we're doing here is multiplying, because when two parentheses are shoved up next to each other, that means that you're multiplying. So multiplying scientific notation, super easy, because you're just going to multiply your constants like normal. So we're going to take a 1.67 times a 3.45, and that gives me a 5.7615. And then you're using your exponent rules for multiplying your 10 bases. So remember, your base stays in your answer. So our base is 10, so we're going to keep 10. And then the rule for multiplying bases is you add your exponents. So 2 plus 3 would give you 5. So the answer that matches that here is letter C. All right, now this time though, when you are adding in scientific notation, you have to have same base to the same power. And the way that we taught it in class is it's easier if you move, or if you change your smaller base to the larger one. So this scientific notation is going to stay the same. So it's going to stay 4.5 times 10 to the 4th. But I'm going to change this 10 to the 3rd to a 10 to the 4th. And when you do that, you have to change your constant, because you want to make sure that this scientific notation, this standard number, still equals this standard number. So if we added 1 to our exponent, that means that we're making this constant larger. So to account for that, we need to make it smaller. So we added 1, so we made it bigger, so we need to do the opposite of that, which is make it smaller. So since we only added 1, we're only going to move this decimal point back 1 to make it a smaller number. So instead of 2.8, it's now 0.28. All right, and then you just add it like normal. So now you add your constants. So a 0.28 plus a 4.5 will give us a 4.78. And then the reason why you had to get same base to the same power is because that stays in your answer. So our answer here is 4.78 times 10 to the 4th. But if you notice our answer choices are in standard form. So what we have to do is we have to then change this number to standard form. So if it's 4.78 and we have a positive 4 exponent, that means we're making our number larger. So if we're making our number larger, we need to move our decimal point to the right, because that would make it a bigger number. And the exponent tells us to move it 4 times. So if I were to move this decimal point 4 times to the right, 1, 2, 3, 4, fill in my zeros, I would then have 47,800. So that is answer choice A. All right, next one. Object A weighs 3.12 times 10 to the 5th milligrams. Object B weighs 2.4 times 10 to the 2nd milligrams. How many times heavier is object A than object B? So first thing we need to do is decide what operation we're doing. So if we're trying to figure out how many times greater object A is compared to object B, we need to do the opposite of timesing, which is dividing. So we are going to take 3.12 times 10 to the 5th divided by 2.4 times 10 to the 2nd. All right, so when you're dividing in scientific notation, you just divide your constants like normal. So if I were to take 3.12 divided by a 2.4, we get 1.3. And then you're just using your exponent rules for your bases. So when you're dividing with the same base, you keep your base. And then the rule for dividing is you subtract your exponents. So 5 minus 2 would give us 3. And they do want our answer in scientific notation. I noticed that my constant is a number between 1 and 10. So that's our answer. So it's going to be 1.3 times 10 to the 3rd times greater. All right, number 11. What number makes a given expression a true statement? So I see same bases here and we're multiplying. So the rule is you would add these bases together to get this space over here. So to figure out this missing base, you would just take your 12 minus your 5, and that would give you a positive 7. For this one, when it says simplify, again, when you're dividing, you keep your base, and then you just subtract your exponents. So if you were to take 2 minus 7, that would give us a negative 5. And remember, we cannot have negative exponents. So since it's upstairs right now and it's happy, you would need to move it downstairs, and then it becomes happy. And then if there's nothing left upstairs, you just leave it as a 1. Okay? So 3 to the negative 5th is the same thing as 1 over 3 to the positive 5th. And notice how none of those match up this one. What they do want us to do, though, is to just simplify our 3 to the 5th. So if we were to take 3 to the 5th power here, we would get 243. So this is just the same thing as 1 over 243, which matches up with answer A. All right, next one is we need to simplify this expression. I see that I have an outside exponent, but I always want to try and simplify anything on the inside of the parentheses first. So like if I see coefficients that I can simplify first, because it just makes it easier when I start to do power to a power. So I see 4 divided by 2 here, so I can just divide those like normal. So 4 divided by 2 is 2. I see same bases, so I can keep that base, and then the rule when you're dividing is subtract your exponents. So 5 minus 3 is 2. And then anything to the 0 power is just 1, so that pretty much just cancels out. So all that we're left with here is 2x squared to the 2nd power. So when you're taking a power to a power, remember you're just doing it like the distributive property. So this outside 2 is going to go to every single thing that's on the inside of that parentheses, including coefficients, because coefficients do have that imaginary exponent of a 1. So when you're taking a power to a power, the rule is you're just multiplying this exponent times every single exponent on the inside. So your numbers stay the same that were on the inside of your parentheses, so the 2 and the x are going to stay. And then you're just taking 1 times 2, which is 2. So it's now 2 to the 2nd power, and then 2 times 2, which is 4. And looking at my answer choices, they do want us to simplify this 2 squared again. So if you just take 2 squared, so 2 times 2, that would give you a 4x to the 4th. So that is letter D. All right, next one is to select all the expressions that are equivalent to 1 over x squared. So we need to simplify all of these. So if I take x to the 4th times x to the negative 6, you keep your base and then you add your exponents. So that would be x to the negative 2. And remember, you can't have negative exponents, so you would have to move it to your denominator to make it happy. And if you notice, x over negative 2 does equal the 1 over x squared here. So A does match up to the one that they wanted us to match it up with. Notice how B was the same exact thing as what we simplified over here in A. So again, B is going to equal that 1 over x squared. So B works out. C, if you were to keep your base and then this time you're subtracting your exponents because you're dividing. So 5 minus 7 is a negative 2. And again, notice how it is going to equal what we've already done for A and B. So C is going to be 1. And then D is not going to be 1 because x squared is just x squared, which is not the same as 1 over x squared. So your answer is A, B, C. All right, the next couple that we have here are some equations. I'm going to use a separate sheet of paper so that I have some more work to show everything. So the first one is 4x plus 7 equals 2 times 2x plus 9. So the first thing that I need to do is simplify by doing my distributive property over here. So the 4x plus 7 is going to stay the same for right now. 2 times 2x is a 4x, and then 2 times 9 is 18. And then I'm actually going to stop here because I notice that I have same coefficient different constants. So if I have same coefficient different constants, that's your indicator that you're going to get no solution. And if you were to actually keep solving it, like if you were to subtract your 4x's on both sides, you would just be left with 7 equals 18, which is not a true statement. So we know that that is going to be no solution. Okay, number 16, so we have 7 minus 4x plus 7x equals a 3x plus 7. I see some like terms over here that I can simplify. So I can simplify a negative 4x plus a 7x, and that would be a positive 3x. And then again, I'm going to stop here because I see that I have the same thing on both sides. I have same coefficients, same constants, which means it's going to be infinitely many solutions. And if you were to continue solving it by like subtracting the 3x's on both sides, you would get 7 equals 7, which is a true statement. So that's your indicator that it's infinitely many solutions. All right, number 17, we have negative 2 times 3x plus 5 equals a 12 minus 6x plus 2. Again, first step is to always simplify, so I'm going to do my distributive property here. So negative 2 times 3x is a negative 6x. Negative 2 times 5 is a negative 10. Over here on the right, I have two like terms that I can combine together. So 12 plus 2 is 14. And then I have a negative 6x. And then again, I'm going to stop because I see that I have same coefficient, different constants. So same thing up here. If you have same coefficient, different constants, that means that you're going to have no solution. All right, and then number 18, so negative 3.5 times x plus 2 equals a 5.75x plus a 2.25. I can simplify the left side by doing my distributive property. So negative 3.5 times x is negative 3.5x. Negative 3.5 times 2 is a negative 7. And all of that is going to equal the right side. Now this time I know that I'm going to get a solution because I have different coefficients. So my first step is moving all x's to one side. So if I move this negative 3.5x to the right, opposite of subtracting it is adding it. So these will cancel. We'll be left with negative 7 equals, and then we would be left with a 9.25x plus a 2.25. Basic two-step equation, opposite of adding 2.25 is subtracting a 2.25. So a negative 7 minus a 2.25 is a negative 9.25. So our last step to get x by itself is to divide by that negative, or to divide by the positive 9.25 on both sides. And your answer will be negative 1, which is C. All right, number 19, have some more equations. So I have 1/4 x minus a 3/8 times x plus 16 equals a negative 7. So again, first step is distributive property. Please don't forget that this 3/8 is a negative 3/8 because of that minus sign. So a negative 3/8 times x is a negative 3/8 x. And then a negative 3/8 times 16 is negative 6. And all of that would equal negative 7. I do have some like terms that I can combine together. So I can take a 1/4 x minus a 3/8 x, and that would give me a negative 1/8 x. And now it's just your basic two-step equation. So first step is to add that 6 to both sides. So we get negative 1/8 x equals a negative 1. And then remember, to get rid of a fractional coefficient, you just multiply by the reciprocal on both sides. So the reciprocal of negative 1/8 is a negative 8/1. So a negative 1 times a negative 8/1 is a positive 8. So our answer here is letter D. All right, number 20, select all the expressions that will result in an equation with no solution. So remember, no solution means same coefficient, different constant. Okay, so in this expression, -2 is the coefficient, so we need to have the same coefficient, and then 5 is the constant, so we need to have different constants. So looking here at A, it has -2 as the coefficient, so those are the same, but it does have the same constant as well where we need it to be different, so A does not work. B, coefficient is -2, so those match up, so that's good. Constants are 3 and 5, which those are different, so that means that B will create an equation with no solution. C, I have a +2 for my coefficient, but we need it to be -2, so C is not going to work. And then letter D, if I were to combine my like terms, I would get a -2x plus 7. So again, I would have same coefficients, but then I would have different constants. So that is exactly what we want, so that means D is also one of our answer choices. All right, question number 21. On Saturday, Megan babysat for 3 boys. She earns a flat rate of $25 for showing up and $3 per hour for babysitting. If she wants to earn at least $49, how many hours does she have to work on Saturday? Write an inequality to represent the information. So remember, I always have us start with the total, because 9 times out of 10, the total is the easiest number to find. And when you're writing an inequality, 9 times out of 10, that inequality word is going to be right before your total. So if it says at least 49, that means that you can have 49 or you can have more than 49. So we know that we need the greater than or equal to sign. Then your next number to look for is the number attached to the variable, because if you know that you're trying to figure out how many hours, you need the price per hour. So they say that she makes $3 per hour, so it's going to be 3x. And then you just need to figure out what to do with that last number. So if she earns a flat rate fee of $25 just for showing up, then you're just going to add on that 25. So looking at our equations, it's not A or B because 25 was not the number attached to the variable. It is going to be D though, because that is the correct inequality symbol that we had. All right, number 22. One of the students below made a mistake in solving the equation. Determine which student made the error. So looking at the equation, we see here that we need to do our distributive property. So when we do our distributive property, 2 times a -6n is a -12n. 2 times a -2 is a -4, so both of them did it correctly. Your next step to get n by itself would be to add the 4 to both sides, which they both did. And then your last step to get n by itself would be to divide by that -12 on both sides. And as you guys can see, Ernie did that, but not Bert. So the mistake that was made was Bert made the error because the student, and then this would be a drop down on your guys' final, he did not divide by the -12 on both sides. Oh, sorry. He made the error because the student divided by 12 instead of dividing by a -12. Alright, number 23, given the equations, find the value of x. So if we tell you guys that y equals this equation and y equals this equation, and as we know, y equals y, we're just going to set these two equations equal to each other and then solve it for x. So this would be 7 minus 3x equals a 2/3 x plus 8. Okay? So this is variables on both sides, so I need to move all my x's to one side. So if I want to move this negative 3x over on the right, the opposite of subtracting 3x is adding 3x. So these 3x's are going to cancel. We're going to be left with 7 equals, and then a 2/3 plus a 3x would be 11/3 x. And then you still have your plus 8. Now it's just a basic two-step equation, so next step, instead of adding 8, is you want to subtract 8. So you're going to be left with a -1 equals 11/3 x. And then your last step, to get rid of a fractional coefficient, just multiply by the reciprocal on both sides. So -1 times a 3/11 is 3/11. Alright, next one, determine the value of a so that the equation has a solution of x equals -4. So if we tell you guys that x equals -4, all that you guys need to do is plug in -4 into all of the x's. So this would be a negative times a -4 minus 2 equals, this would be a -4a plus 10. Alright, so next thing that we need to do is just simplify this left side of our equation. So think of this as like a -1. So we're taking a -1 times a -4, which is a +4. And then 4 minus 2 would just give us 2. Alright, so now this is just a basic two-step equation. So I'm going to move it over here so I have some room to show my work. So I need to move the 10 first, so the opposite of adding 10 is subtracting 10. So 2 minus 10 is -8. I'm going to drop down that -4a. And then our last step to get a by itself is to divide by -4. So -8 divided by -4 is a +2. Alright, and then our last two questions here. So Chad is choosing between two cell phone plans. For 1 month, Plan A charges $29.95 with each text costing 10 cents each. Plan B charges $49.95 each month with each text costing 5 cents each. How many texts must be sent for the plans to cost the same? Okay, so these will be a drop down for you guys to choose between. So the first part is defining the variable. So defining the variable is trying to figure out how or what you're trying to find in the problem. So we're trying to figure out how many texts must be sent for the plans to cost the same. So we're trying to figure out the number of text messages, so not months, gigabytes, dollars, cell phones. This needs to be fixed, so it needs to be number of text messages. Alright, and then our equation. So Plan A is $29.95 plus additional 10 cents each month, and then Plan B is $49.95 plus an additional 5 cents each month. So the equation that matches that, I forgot my X, is this one right here. Alright, so our last part is to just solve it like normal. So I'm going to start with my equation that we had up above. And then our first step is to get all x's on one side. So I'm going to move this 0.05x over here with the 0.10x. So opposite of adding it is subtracting it. We're going to be left with this $29.95, and then 10 cents minus 5 cents is a 5 cents x. And all of that equals a $49.95. Now it's just your basic two-step equation. So first step is to subtract the $29.95 from both sides. And we'll be left with 5 cents x equals, and then this would be $20. And then our last step is to divide by that 5 cents on both sides. So $20 divided by 5 cents gives us 400 text messages. Alright, so that is your study guide. Let your teacher know if you have any questions.